Okay, I do recommend you click on this link over here. The guy that went through this, typical integral, by the way, but I would say that he offers, a different, I'm not going to say a different approach, but a different way of doing what I'm doing. All right, so it can't hurt to look at other teachers, by the way. That's what I want to say to you. And also look at other books as well. The first thing I would do in a problem like this one over here is I would do the partial fraction decomposition. So again, it looks like the last problem, but it's much simpler because it's an x cubed plus 1, and that's something that you should know how to factor at this point. That factors x plus 1 times x squared minus x plus 1. A very simple factorization. So I would try to do partial fractions. Let's say x cubed plus 1. I would say it's equal to a over x plus 1, and then plus, and then it's going to be bx plus c over x squared minus x plus 1. I'd clear the fraction by multiplying by the LCD. You would get 1 equals a x squared minus x plus 1 plus bx plus c times, x plus 1. And then I pick easy numbers. The first number I pick is minus 1. If you did that, you would get 1 on the left side. On the right side, the second term would disappear. The first term would become 3a. And that means a is 1/3. The next number I choose is x is 0, because I think it's easy to deal with. And what would you get there? Well, you get 1 on the left side. And then let's see what you get. You would get 1 times a, which is 1/3, plus c. And then let's see, if I said 0, that would be, just be 1. So I know c is going to be 2/3 now. All right, I've kind of exhausted the easy numbers. I'll pick another number now. I'll pick 1. You still get 1 on the left side. On the right side, what do you get? Well, let's see. 1 minus 1 plus 1 is 1. So you get 1/3, because a is 1/3. Plus, again, x is 1, so I get b plus 2/3. And then 1 plus 1 is 2. Again, more challenging. So let's just go through it. And it gets 1. That's 1. This is 1/3 plus 2b plus 4/3. Well, we get 1 equals, let's see, 4/3 and 1/3 is 5/3 plus 2b. And let's see what you get over there. I'm going to subtract 5/3 from both sides. That's minus 2/3 equals 2b. And the b is minus 1/3. All right. Let me show you this is written down. We just went through the work. We found the a, if you recall, to be 1/3. That's written over here. We found the b, if you recall, to be minus 1/3. And we found the c to be 2/3. It's written over here. So the only thing I did there, let me just erase the work now. I'm kind of done with that. And this is just, going along in steps, all right? Just like we did the other one. This is going to be far easier to deal with, though, all right? Remember the last problem was much more difficult. So what I do is write it down. And what does that mean? I'd write this down. Equals, well, what's a? A is 1/3 over x plus 1 plus, well, b was minus 1/3 x, and c was 2/3, right? And that's over x squared minus 2x plus 1. And I would factor out 1/3, actually. Makes it easier for me to look at it, actually. Not deal with, but look at 1/3. Also to typeset it. It'd be 1 over x plus 1. And this would be minus. I like to pull a minus sign out. And that would be x minus 2 now. Over x squared minus 2x plus 1. All right, so I'm at a good place now. I'll tell you why I'm at a good place. I know how to integrate something. I certainly, because our intention is to integrate this. I certainly can integrate this. And this is looking somewhat familiar to me. So I need to rewrite it. And let me go through that with you. So rewriting this term, the second term, does take some effort. Now, before I go and do it, I'm going to start to erase this because I'm pretty comfortable. I'm at a stage where I can actually move forward. But I want to write down what I'm looking at. I'm looking at the bottom of that second term, which is x squared minus x plus 1. And if you differentiate that, right? Like if I made this a u, which is really my hope, I get a u substitution somewhere, du would be 2x minus 1. But you know what? I'm not seeing 2x minus 1 here, right? So what I did was I multiplied the top by 2 and the bottom by 2, all right? Now granted, when I do that, I'm really multiplying the top by 2. I'm going to leave the 2 on the bottom still. So it's going to be 1/2, and then you would get 2x minus 4 over x squared minus x plus 1, all right? That's where this is coming from here. I see that there. But you know what? I got too much. So what I do is I kind of just write it over again. So I write down 1/2. What do I want to see? I want to see 2x minus 1, but I have a minus 4 there, so it's minus 3 over x squared minus x plus 1. And you can kind of split this into two terms now. I'll write that down for you. 1/2, 2x minus 1, x squared minus x plus 1. And then what do you get? Let's take a look at that. You would get minus 1/2. I'm pulling the minus 1 out. 3. And then you get x squared minus x plus 1. Let me show you that's written. Again, we took the term and we got this written over here, which we want to come up with is over here. And then I got this 1/2, and I got this guy over here. So I'm pretty comfortable moving forward to that level. All right. Now again, you may not recognize everything in the problem, but you recognize some things now. At least I hope. All right. So what am I recognizing? Certainly, I can integrate. You know, this guy. This guy I can integrate now, but I'm looking at this other guy, and I'm starting to think to myself is, like what I've always done is, I've always completed the square, right? So let's go through that, and we'll rewrite this. So we're going to try to rewrite this guy over here. And let's write that down, all right? So it's going to be 3, and then I can complete the square, so it's going to be x squared minus x, take half of minus 1, which is minus 1/2, and square it, you get 1/4. Well, I have 1 there, so I got to put 3/4 down. Right, so what is this going to be? It's going to be 3, and then it's going to be x minus 1/2 quantity squared plus 3/4. Now, I'm of the opinion that the 3/4 should be factored out. All right, now not every teacher does that, but let me point out what I mean by that. I factor out 3/4 from the bottom because I want this to look like this over here. I know that guy really well. It's the arctangent. So I'm going to factor out the 3/4, and that means you get 4/3 times x minus 1/2 squared plus 1. All right? And it kind of looks strange to me, so I'm going to keep rewriting it. And the first thing I notice is, 3 divided by 3/4. Well, let's write this down. 3 divided by 3/4 is the same thing as 3 times 4/3. So it's really just going to be 1/4 now. All right? And what do you get over here? You get 1. And at the bottom, you get plus 1. And what I'm going to do, I'm going to try to integrate this thing on the inside. All right? So 4 is actually 2 squared. And the 3 on the bottom is going to be root 3 squared. And that's what I'm pulling out to the inside. So what would you get over there? You would get 2x over root 3 minus, well, let's see, the 2 would cancel, so you get 1 over root 3 squared. Again, we're pulling this on the inside. So when we're pulling the inside, really pulling 2 over root 3 on the inside. So that kind of simplifies pretty nicely, by the way. All right? So this whole thing here, oops, sorry about that. Let me back up a little bit. This whole thing here is just this guy over here. And, certainly, looking at that, let me see if I did that okay. Yeah, I got 4. Yeah, that looks okay. And so what I'm going to do over here is I'm going to multiply it by 1/2 now. Let me see if I did that right. I think I might have made a mistake somewhere. Let me go forward. I really have to go forward. So we just did that. I'm going to look at it again to make sure I did everything okay. And that's 4/3. I'm sorry, I see the mistake now. It's 4, it's not 1/4. I'm glad I noticed it. All right, let me erase this over here. All right, let me point out that I said something. This is actually 4, and I said 1/4. So this is 4, all right? Now what am I doing there? I'm going to multiply it by a half now. So I'm going to multiply it by this over here. So I'm going to write this down, 1/2 over here. What happens over there? You get 2. And let me show you where that is. That is right. Let me make sure I'm saying that correct. I see the 2. I see this 2 here. I see this here. And I see the +1. All right? So I'm in a good spot. All right? What I did was I split it into 3 terms now. And let me just write that down for you. Right? So this over here, you know, if you go back, we did this before. And then I split that second term into these 2 terms. And what I'm going to do now is multiply through by a third. All right, so 1/3 times the first one. You know, 1/3 times a half is a 6. That's not so bad. And then 1/3 times that last term is 2/3, this guy over here. And I get, you know, I'm going to say that the first 2 integrations, relatively simple to do. All right, relatively simple to do. And so let me just do this one over here. And what's that going to give you? You know, 1/3, right? 1/3, the natural log of the absolute value of x plus 1. That's simple to do. The next one's also simple to do. It's -1/6. And what do I notice about this guy over here? This here, right, if I let that to be u, its derivative would be 2x minus 1, which I see that over there, right? So what's it going to be? It's going to be the natural log of the absolute value of x squared minus x plus 1. Now, certainly, I want to point out to you that x squared minus x plus 1 is always greater than 0. Now, someone says, how do you know that? We already complete the square on it, and we know it's always going to be positive. We know it. All right? We don't have to go through looking at discriminant of that one over there. So I can use parentheses on this guy over here. All right, let me show you where those 2 are. I have that one here, the first one, and then I got the second one over here. All right? I want to do the third one. The third one's a little more complicated for me. Let me get my eraser out, get rid of the distractions. And I want to do that third integral. All right? I'm looking at the integration. All right? What integration I'm looking at? I'm looking at this guy being integrated now. I'm sorry, this guy being integrated. Let me get my eraser out. So what I would do there is I'd let a u substitution, and I'm going to write this one down for you. So I'd let u equal 2x over root 3 minus 1 over root 3. And why do I want that? I want to see this over here, and I will see this, by the way. All right? Now, what is the derivative going to be? du is going to be 2 over root 3 x dx. I'm sorry, not x. I made a mistake there. Let me erase that again. That would not be good. It's 2 over root 3 dx. So what's the du going to be? It's going to be root 3 over 2. You know, and this is what we're integrating over here. But you know what? I already have a 2/3 there. All right? So what are you going to get? And again, this is a star over here. The 2's cancel. Root 3 over 3 is 1 over root 3. And you're going to get the arctangent of the u. And what's the u? It's this thing over here. So let's make sure we see that. I'm seeing it here. And I'm seeing the arctangent of this argument over here. And of course, at the very end of it is plus c. All right? Now, certainly, you know, this is just me. I look at these problems and I realize I work through step by step on it. And the problem with doing step by step is, you know, maybe I made a mistake. Maybe things are just working too nicely. I don't want to believe that. But what I did was I went to Sage. And what I did, I asked Sage to integrate it. Certainly it does it way quicker than I could ever do it. So what I want to do is I want to look at my output from Sage and to see if I have this stuff over here. Let me erase all those distractions now. All right? So I want to point out what I'm looking at. The first thing I'm looking at when I did it, I'm going to look for the simplest term right over here, plus this one over here. Do I see that? You know, they're not using the absolute value symbol. That doesn't bother me too much. I see this over here. I definitely see that. Do I see this term? And I do. I see it right over here. The natural log of x squared minus x plus 1 over 6. I definitely see that. Now, I realize some people say, this is confusing, but I definitely see this. All right? I mean by that, I definitely see the arctangent. I want to make sure I'm seeing what they say I'm seeing. And the way I read this over here, it looks like 1/3 root 3 times 2x minus 1. All right? Now, by the way it's written, I mean, they're rationalizing it, but you could write this as, let me take a look at that. You could write it as 1 over root 3, 2x minus 1. And would I get this over here? I certainly would. Would I get this? I certainly would. Let's look at the coefficient in front, though. This thing over here. I'm saying this over here. Where they write down 1/3 of root 3, which I wrote down as 1 over root 3. It's identical. All right? Everything worked out as advertised. Thank you.